let's discuss the idea of why d2y by dx square determines maxima or minima. So let's understand the basics. Let's say y is the curve. Y represents any curve on the graph. dy by dx will represent the slope or the gradient. So now d2y by dx square can be said the rate of change of slope. But let's try to understand what that actually means. Why is it called curvature? Why do we use it to analyze maxima minima? So let's understand what is happening over here. I'll say this is the initial point and let's call it the final point. This line represents slope. This dotted line represents another slope. Now as we know that the value of tan at 0 is 0 and tan at 90 tends to infinity. So I'll just write the symbol of infinity to represent that tan at 90 is approaching a very large number. So now as we can see, the slope was this and became this. So now the slope is increasing. So now because the slope is increasing, we can say that the slope was positive, and because it is increasing, y double dash is also positive. The rate of change of slope is also positive. Now let's have a look at this. In this second case, I'll call this as my initial point and I'll call this as my final point. If this is my initial point and this becomes my final point, what is the slope? Since there is no rise for run, what is the definition of slope? Slope is rise upon run. And as we observe, as x is increasing, y is decreasing. So the slope is negative. So I write y dash is negative. Since y dash is negative, now let's observe the second case, that is y double dash. In case of d2y by dx square, the slope was this and became this. Earlier this to this. And as we know, in the second quadrant, the value of tan goes from, this is going to be negative infinity to 0. So it is going from negative infinity to 0. So because it's going from negative infinity to 0, it's actually increasing. So because it's increasing, d2y by dx square will be positive. That is the reason why when d2y by dx square is positive, we get minima, because it is upward open parabola. Because d2y by dx square represents open upwards, that is the reason why I'm going to get the minimum value at this point. Now let's move forward to the next one. If I have such graphs, during such graphs, let's call this as my initial point and this is going to be my final point. This is the slope and this is how it changes. The slope is positive because the definition of slope is rise over run. As we analyze, there is going to be rise for every unit of run. So the slope is positive. When we talk about d2y by dx square, let's just see. The slope is going from here to here. In the first quadrant, the value of tan is goes from here to here. That means it is going from infinity to 0. So it is decreasing. So the rate of change of slope d2y by dx square will be negative. Now let's analyze the second one. In this is the slope of initial point. This is the slope of final point. As we analyze, both of these slopes are negative because there is no rise, it is just falling for every run. So the slope is going to be negative. If I talk about y double dash, that is going to be d2y by dx square. If we are considering d2y by dx square, let's analyze what is happening. It is going from here to here. That means the angle is changing in this manner, from this to this. That means from 0 to negative infinity, which means it is decreasing. Since it is decreasing, d2y by dx square becomes negative. And that is the reason why if d2y by dx square is negative, this point represents the maxima. That means downward open curvature or downward facing parabola represents maxima, since d2y by dx square is going to be negative in both the cases. Thank you. Let's ponder about this concept. If we have to express d2y by dx square, that is a higher order differential. dy by dx means the slope of a curve. d2y by dx square, what does that mean? d2y by dx square implies the curvature of any slope. That we'll discuss in the next video. Let's focus at expressing this in terms of differential coefficient of x with respect to y. If I have to express that, we have to remember that d2y by dx square is not equal to 1 upon d2x upon dy square. So let's try to visualize what's happening over here. This is a higher order differential. That means y has to be differentiated 2 times. Once y has to be differentiated with respect to x, that will give us dy by dx. Then I'm going to differentiate that dy by dx with respect to x again. So I'll get d2y by dx square. So what I just said, d by dx of dy by dx. Now I have dy by dx over here and dy over here. Now this dy and this dy won't get cancelled because we all know that this is an operator. D divided by dx is an operator, and since this is an operator, we have to apply this as an operator to anything over here. This is not null set, I'm just representing it with a symbol. So now the symbol over here transforms into dy by dx, and this is dy upon dx. Now, dy upon dx can be written as dx upon dy to the power minus 1, which we have discussed in the previous videos. And over here I have dy by dx. If I differentiate this, that is x to the power minus 1, what do I get? Minus 1 into x to the power minus 2. Over here, the variable is dx upon dy multiplied with, as the chain rule says, I have to differentiate dx by dy with respect to y. So I get d2x upon dy square. Now this is what I get from this term. Dy by dx can be written as 1 upon dx dy. Since the power of this term is minus 2 and this is the exact same term, I'll write it as dx divided by dy whole cube, and this higher order derivative comes exactly in the same manner. This is the negative sign copied from minus 1, so we can say that d2y divided by dx square, if it has to be expressed in terms of differential coefficient of x with respect to y, can be written as negative d2x by dy square dx upon dy the whole cube. Thank you.